Okay, we're at Boykin Springs Recreational Area on the Angelina National Forest. It's an actively managed red-cockaded woodpecker site, and fire is a common tool that they use to maintain these kind of habitats for this endangered species. It's also a good site, since they use fire, to talk about fuel loading as how to quantify that. There's a lot of different methods that are used. But in the 1970s, a group of researchers developed a method that on how to measure everything from above ground, overstory, mid-story, regeneration, down woody material, and herbaceous material, and the amount of litter and duff on the ground. The stuff that Dr. Farish calls the O horizon, but fire people like to call litter and duff because Dr. Farish doesn't like the word duff. The method is called the Brown method. So you can go any place in the world and you say, oh, how did you measure the down woody material? And you say, I use the Brown method. Everybody goes, fine, I've got that figured out. The mathematics behind this whole field method is based on regression. So this allows you to take a subsample and plug it into a formula and then expand that out to in our case, pounds per acre. On a lot of this, the down woody material. Down woody material is classified by the size that they have in diameter, and that relationship is tied to the diameter and how long it takes for that material to reach basically an equilibrium with the environment. We often call that a time lag relationship. So very small diameter, less than a quarter inch in diameter, is what we call a 1 hour fuel or a 1 hour time lag. It's basically reflecting the environmental conditions 1 hour earlier, but how the moisture is that. It's not equal, it's equilibrium. And then 10 hours, which is the fuels that are between a quarter inch and an inch, it's obviously 10 hours, 100 hours, and then 1,000 hours, and we'll talk about 1,000 hours in a little more detail in just a couple of minutes. What we're going to do is demonstrate how you would do this in the field, and then for the lab exercise you're going to get a real data set that was used in a previous field station to do the quantitative assessment and the calculations on that one. So it involves some really high-tech equipment. It requires a tape that you spread out at 50 foot. It requires these frames here that are 2 foot square to do the litter and the herbaceous vegetation. And then it requires this highly technical tool, which we call a go-no-go gauge, which is designed in plastic and cut to extreme accuracy. For how to get the diameters on that one. So the space right here is a quarter inch, that's an inch, this is 3 inches. So this is how we look at and try to count the 1 hour, 10 hour, and 100 hour fuels. So I'm going to have a couple people go through, and they are going to measure first the 1 hour fuels, which are based on the first 6 feet of the length. You can do any length. The standard is 6, so why don't you just go ahead and do that, see if there's any. And then in this case, you get the actual number of counts. You do not want to move the fuels. You count them where they are. And in this case, is the first 6 feet. 1 hour fuels. Okay, how many do you have?
I have 3 10-hour fuels and 0 1-hour fuels.
Okay, so within the first 6 feet, those are the counts. Now, for the 100-hour fuels, you go 10 feet down. So, is there anything that falls into that category in on this plot right here?
I do not see any 100-hour.
I don't either. So, why don't we go down to an area? We do have an area where we do have a 1,000-hour fuel, a tree that fell over, and we'll talk about how we measure that. All right, 1,000-hour fuels, which are fuels that are bigger than 3 inches in diameter, are measured a little bit different. Mathematically, they have to be, and then we have to account for them a little bit different as well. Because the decomposition of woody material breaks down and first goes to cellulose and then you're left with the lignin. The smaller diameter fuels have very little of that ratio of the lignin versus the overall woody material in it. As you get above 3 inches in diameter, the amount of lignin that's left there is substantially higher as a rate of the whole volume. So if this tree fell over and over time it will start decomposing, but the first material that decomposes is going to be the cellulose. And so basically what you have to do is you have to check, this is another way to make sure there's no snakes right underneath it, is go ahead and give it a little kick. If it's solid like that, you would count that as a solid log. If it was hollow sounding, you would call that as a rotten log, because that would be the cellulose has dropped off, and how it burns is going to be a little bit different, because the more cellulose it have, the more likely you're going to have flaming combustion. The more, if it's mostly just lignin, you're going to have more glowing combustion. The mathematics are a little bit different here as well, is that it's not the number of counts that go in, it's the measurement of the diameter that crosses the line. So you want to, how many, what's the inches?
About 15 inches.
Okay, so you would record that as 15 inches. The mathematics in this is that you will square every 3 inches and above number, accumulate all those, and then plug that into the formula rather than just calculating the number of hits you have on this one. And so why it went ahead and estimated that is that a couple things you may have seen earlier is remember larger logs, number one, it's not the diameter that you would measure in Forestry 111 and biometrics and all the other classes. It's the diameter that crosses that line. So that's substantially a different quantity. So if the line is running at an angle, it would be bigger than the actual diameter of the tree at that point. You put these lines down in the field randomly. You do not just say, I'm going to put it here. I did for this exercise because I wanted to be able to measure these different sizes in this. Another thing that may happen, and it was on one of the earlier slides, moments when we were looking at this, is that we had a branch that curved around and came back and crossed the line at another point. That would count as 2 hits, not just 1. And so you plug that all those numbers in, add them all up, and that'll give you in pounds per acre of woody vegetation. Now we're going to talk about how we do herbaceous and litter. Okay. Herbaceous vegetation is using these 2-foot squares, and what you're doing here is getting an average assessment of the herbaceous vegetation, and we'll use the same methodology for the litter material. At one plot, which this whole thing represents, we're using these 4 subplots to catch up that variation. So the first thing you do is you look for the plot that has the most herbaceous vegetation on it. And so this is the one right here?
Yes, this one is about 100%.
Okay, so you would say this is your standard. This is the one that if you really want to get weights on, you would end up clipping. But you don't want to clip it first. You want to see what the other ones are in comparison to this standard plot.
Would you agree this is the second one, the most herbaceous cover?
Yes, I would agree.
And what's the percentage of that compared to this?
For that one being about 100%, this one would be about 25%.
I'd agree.
Okay. Okay, and then what's the next one?
The next one would be this one right here, and there would be less than 10%. And then for this one over here, since it's a fern growing through it, it would not be considered technically herbaceous, so it would be less than 5%, just square.
Okay, so what you do with this assessment is that you've got one subplot that you're going to clip, weigh, dry, and get the dry weight. Then you've recorded the percentages of the other 3 plots, and so once you get this dry weight, it's going to be the different percentages that you're going to put together and sum them up, divide by 4, and that represents the average herbaceous vegetation that is found at this plot. You would do the same methodology for the litter. Now, which ones do you think is the one with the most litter? Well, Hannah gave one example because the assessment and collecting could be just on one half of these. You get 1 square foot. The other way to do it is say which one is going to have the most overall and then just collect on one. Either way is acceptable as long as you are consistent. So you think this is your standard. So this is the one that you're going to be collecting the same procedure of using that as your standard, and the other ones are percentages of those. If that's your standard, what's the one over here?
Almost equal to the standard.
Okay, so you could say 100%, you could say 95% if you wanted to do that. Either way is fine. What it comes down to when you start taking these weights and blow them up on a pounds per acre basis, a ton here and a ton there may finally make a difference in how the fire is going to behave. If these are basically the same, what about the one here?
Say it's almost equal to, a little bit more.
Yeah, I think that's fair. Now, what about your herbaceous standard plot?
This one is less than standard because the herbaceous cover is overlapping the litter cover.
Okay, so what percentage would you give this?
Less than 10%.
Yeah, 10-15%, probably a good guesstimate on that. You're just doing an eyeball estimate on this one. The one thing to keep in mind is that what we've done here is assessed cover of the subplot. What we don't have any measurement of, and it's not necessarily required for this, but you should be conscious of the difference, is that we're not getting total biomass of litter in here because we didn't measure depth of the litter in these plots. We're just looking at this from a cover standpoint and measuring it that way. So essentially that's what the methodology was used that is going to be supporting the data that you are going to be given for the lab assignment.